CERN, the European Organization for Nuclear Research. This is where you find the world's highest energy particle accelerator, the Large Hadron Collider, and thousands of scientists trying to answer the fundamental questions of our universe. Using the LHC, protons are accelerated up to 99.999991% of the speed of light in a 27-kilometer long ring 100 meters below people's homes. Two chambers within the ring allow for proton packages to be accelerated in opposite directions at the same time with an energy of 7 tera-electron volts each. This allows for collisions at the 4 crossover points with energies of up to 14 tera-electron volts. At these collision points, the 4 detectors are installed. The two biggest ones are general-purpose detectors, Ellis and CMS, which are able to detect a range of different particles and were designed independently to ensure that detected events are not artifacts of the detector design. Hence, in 2012, when a signal was detected in both CMS and Ellis, it could be unambiguously attributed to the Higgs boson. The other two detectors were developed with a focus on specific phenomena. Ellis, designed to collect data on a particle state similar to the state of the universe just after the Big Bang, and LHCb, built to investigate the properties of antimatter and solve the question of matter-antimatter asymmetry in the universe. The 14,000 tons CMS detector is the heaviest, although only the second largest detector. It was built in slices on the surface and lowered down to the LHC. High-pressure air cushions can be used to move thousands of tons of electronics to open the detector for maintenance. Up and running, it detects 40 million proton collisions per second, and the computer cluster, separated from the detector itself by 7 meters of concrete, analyzes and discards almost all of the data on the fly. About 100,000 events per second deemed interesting are subjected to a more detailed analysis and event reconstruction. But only up to 100 events per second are saved for the complete analysis by hundreds of scientists. With an uptime of 200 days a year, petabytes of data still accumulate. So what does the future of CERN look like? The LHC is expected to run another 20 or 30 years, while among other experiments, scientists are looking for hints of supersymmetry or extra dimensions of space to explain the origin of dark matter. There are two proposals for the future of CERN. The acceleration of protons to even higher energies using an even bigger accelerator could facilitate the detection of events yielding new hints towards the fundamental principles of our universe. The Future Circular Collider, or FCC, would have a circumference of 100 kilometers and it would take several decades to build. The alternative would be an electron accelerator. The Compact Linear Collider, or CLIC, would consist of two linear electron accelerators facing each other, accelerating the electrons with only one pass-through and making them collide in a central detector. Electrons, as opposed to protons, are fundamental particles, hence, electron collisions would be much easier to analyze. Chances are, the cheaper option will become reality within the next 50 or so years. Thank you for watching, and make sure to subscribe for future updates from the Frontlines of Science. On February 11, 2016, the Laser Interferometer Gravitational Wave Observatory, or LIGO in short, published the observation of a signal that could be caused by gravitational waves passing through Earth.